thank you for coming. And wow, this is a big room. So we have it. So this is something that's very important for the city, because obviously fresh waterways is a huge issue, and there's just a lot of things that we need to deal with, and there's just multiple things that we are working on as a city, and this is one of the first parts of what we're working on, and there's multiple things that we're going to need to do to come up with solutions, and we don't even know what those solutions are yet. But again, this is how that we go through the process to do it, and I'm very excited about having this presentation, and it's not going to answer all your questions. It's you know, basically vegetation. But I'm going to turn this over to Steve, and Steve can introduce our guest to do it, and we'll have question and answers, and we'll take comments, and this is just the process.
Yes, sir. Good evening, everybody. Thank you very much for coming to the IAVMP presentation, the Integrated Aquatic Vegetation Management Plan. So really quick, I am the chair of the Fresh Waterways Advisory Board. We have almost all advisory board members here tonight, missing one. And then also back there in the back row, we have Bruce Malloy, who's the president of the Fresh Waterways Corporation. And so we have been working with the city to get this IAVMP completed, and here we are. Terry McNabb, who is the gentleman, his company was contracted to complete the IAVMP, and tonight is very important because it's your opportunity to give your concerns and your comments about the weed issue in the waterways. So first, Terry, he will have a quick presentation, and then he's going to open it up. So everyone, Mr. Terry McNabb, Aquatech next.
Sorry. I don't know how quick I'll be. Thanks, Steve. So I'm going to spend about 2 minutes telling you who we are. I'm going to go through the process that the Department of Ecology wants groups like yours to go through in terms of developing these plans. I'm going to kind of then spend some time on what we found, which drives the types of solutions you've got available to you. And we're going to touch on the different aquatic plant and algae management options that are available. But one of the key things about finishing this plan is the Department of Ecology wants to make sure that the community is heard from. And there's a lot of different types of technologies you can use to deal with aquatic vegetation problems, and you know, people have opinions about them, and that's kind of what we want to capture here tonight. So I'm going to probably talk for a half hour or so, and then we want to open it up to the floor, and we've got a recorder here that's going to try to capture comments, concerns, those types of things, and then we're going to button this thing up and finish writing it and get it back to the group that they can start to implement it. So Aquatechnics is a lake management firm. We're based up and down the West Coast. We've got a number of offices in these states, and our primary mission is to help lake associations, government entities, and things like that deal with lake management issues, whether it's noxious weed problems, harmful algae blooms, things like that. That's kind of who we are. This side's just me. It just tells you I'm old. I went to college for this. I've been doing it for quite a bit of time. And we've served on the board of a number of the professional scientific societies that are involved in this. So, and I'm also an instructor. I teach I teach the lake management course for the National Golf Course Superintendents Association of America. And I'm on the faculty of University of California, Davis Aquatic Weed School that's taught every year. So the last introductory thing I want to throw in is we've had the U.S. Army Corps of Engineers they own more water than anyone in the world. And we've had a contract with them since the early 1980s every year to support their aquatic plant control research program. So we've been heavily involved in the development of a number of the different technologies that are used to control aquatic plants. We helped them build the HARVEST model, which is a computer simulation model that people can use to determine how harvesting operations would benefit them, things like that. But that's something that's we've really gained some knowledge from over the years. So let's get to this thing. You guys have gone through this process twice before. About 1994, your group got a grant to write one of these integrated aquatic vegetation management plans, and we were subcontracted to do a lot of the mapping work. So we were out here, what, 20, 30 years ago, collecting data. At that point, your lake was overrun with an invasive weed called Brazilian elodea. And we went through the same process. We looked at all the control options, and the community basically came up with the concept of using triploid or sterile grass carp to deal with the weed. It was a really widespread problem. It was a cost-effective solution, and that's what the community picked, and that's what they implemented. Another IVAMP draft was done about 2009, and at that point, I think from reading the documents, the grass carp had kind of died off and weren't being very effective anymore, and it kind of shifted to another noxious weed, Eurasian milfoil, which grass carp don't like and don't eat. And revamped your thing and kind of went through with a herbicide program. And then the city put out an RFP last year. We responded, and they basically picked us. So just another couple quick comments. These are the problem statements that were in place from the last one you guys did. And the problems from our survey work, which I'll get into in a minute, we didn't find any of these weeds out there at densities that were problematic. So the work you've been doing has kind of shifted, you kind of shifted the process away from the things you were dealing with when you wrote the last IVAM statement. So Department of Ecology has a manual they published that they like citizens to go through. It's got a bunch of steps to it, which makes sense. And these are the steps we pretty much went through. You have to put a steering committee together, which your group did. You have to come up with a problem statement, which I'll show you in a minute. And then you go out and basically identify what the problems are in the lake, the scope of the problems, how widespread they are. You get the geography all organized, because that leads to costs for all the different types of technologies that you might implement to go after them. But the process that we're following is outlined in this document here. So your steering committee, after a lot of discussion, we're sitting as a group. It was pretty well represented, I think, of the people here. What are the problems that you're experiencing in the lake from these weeds, from the aquatic weeds you're out there, and what are the beneficial uses that are being impacted by them? And this is the list that your steering committee came up with, and they're pretty straightforward. Boating is kind of a key thing, both for the residents on the lake, and the lakes are kind of a magnet for tourism. A lot of people come in or kayaking and things like that. Fishing is very important, and vegetation is a kind of a critical component of the habitat that different types of fish need to thrive, I guess is the best word. Ecotourism is something that's more and more happening around here. A lot of people are coming here to look at the birds and things that might be around the lake. The city is in the process of developing more parks. It was one of the things that was brought up where access to trying to maybe improve some of the access to the waterway. And then kind of a key thing here, swimming is kind of lower on the list, but people do it, and aquatic plants can have an impact on that. There's a number of drowning deaths every year directly attributed to people to get tangled up in plants like Eurasian milfoil in our state, for example. And then lastly, we touch a little bit on harmful algae blooms. So I don't want you to have to read this, but the problem statement is something that was developed by the steering committee, and we're going to make this available. I think the city wanted to get a copy of this and put it up so you can read it later. But basically, this kind of drives. So once we've got our beneficial uses organized, we start looking at, well, what are the problems that are impacting these beneficial uses, and primarily, if you've got heavy aquatic weed growth, it impacts all that stuff. It impacts your access for boating. The level of weeds in a lake can have a real important impact on fisheries. They can, too many plants, too few plants can have a huge impact on that. And then, lastly, the cyanobacteria or toxic algae is something that's more and more concerned lately. So we went out and collected a bunch of different pieces of information that were critical to come up with the numbers you would need to make financial decisions about the different control options. So we did what's called a hydroacoustic mapping process. We went out before you did your treatment this year. In our boats, we run a bunch of transects with a sonar system, and it records what's going on there, and it builds a number of maps that we use to calculate the volume of the lake, which you need to make decisions on things like additives. It helps you calculate the number of acres, and it shows you what % of the water column is impacted with plants. And then we also went back and mapped the species we found, so we've got some idea of different herbicides, for example, work on there's different types of plants that may or may not respond as well to one of the herbicides, things like that. Same with harvesting, and then grass carp have feeding preferences, so that's kind of important to know what the species are. We also did some water sampling, focusing on the cyanobacteria program and kind of to look at where the lake was in terms of nutrient levels. And then we installed a couple of algae tracker buoys that I'll get to in a minute as we kind of get into this a little bit. So this is an example of the bathymetry map that was created, and when you're looking at the bathymetry map's the shape of the lake bottom. And in order to get this all on one slide, you've got to look at the whole bloody peninsula. But if you start zooming in on this on the computer, it gets really pretty sharp. It's 1 foot contours. But that's the first map that this thing generates. And you get an idea of where, the whole system's pretty shallow. And, aquatic plants can only grow up to a certain depth because of the light. They need light to photosynthesize. If you get down deep enough and there isn't enough light, and they don't grow down there. So it's kind of important to look at the bathymetry. And what you'll see here is most of the lake's shallow, most of the lake and canal system is shallow enough that you can get aquatic plants through the entire water body. And if you get on Duck Lake, the deeper areas, you won't necessarily see stuff. The next map that it generates is an aquatic vegetation biovolume map. So this map, if you look over on the side, there's that heat ramp there, the color chart. So when you're looking at this map, the way the hydroacoustic system, if you're looking at the blues out there at the bottom end of that ramp, that means there's no vegetation present at that point. As you kind of come up the ramp, what you can envision is as the colors get more closer to the top, that's the plants filling the water column. So if there's areas that lake that, for example, are on the greens, that means that their plants are maybe 25% of the water column. They're down there, but they're not up to the surface. If you get to the reds, that means that the plants are topped out at the point of the survey. So that's kind of the key thing, because it shows you where the plants are, it shows you where the problems are, and it starts getting you the number of acres you need to make decisions on treatment. It also kicks off a sediment hardness map, which can be critical when you start looking at algae. Some of the algae stuff I'll talk about in a bit. But sediment hardness is pretty much a function of organic soil. So what you see on this color ramp is the darker it is, the harder the bottom is. The lighter it is at the bottom, the softer it is, and that's organic sediments that are probably cycling nutrients back into the system over time. So those are the three maps that were made. And that just brings us to what we found. So the surface acres in the lake are approximately 482. We've got a number of acre feet of water, which is important when you start thinking about dosing a lake with something to get rid of, like phosphorus, for example, so that number's in there. We calculated that about 59% of the acres supported aquatic plant growth at problem levels. So maybe not quite half of the acres you've got out there are problematic, but you can kind of see that Duck Lake vegetation isn't that much of a problem. The canals, it's quite a bit more of an issue. So the acres of aquatic weed presence are 284, and if you start doing the math of whether you want to treat, you need that to know, how, it helps with budgeting, because everything's got a number based on acres pretty much. And then the primary problems are over the canal system from an aquatic weed standpoint. Years ago, you had two noxious weeds in there. They're listed by the state of Washington and also the federal government. Brazilian elodea was the first one you went after. It was a plant introduced from South America. The aquarium trade, people would they'd buy it. Kids would take their fish out and like Free Willy, they dump it in the lake, and the stuff grows rapidly and it spreads by fragments, so it's spread around pretty rapidly. And that's the first thing you guys targeted with your grass carp. We saw almost no Brazilian elodea out there. There is a native, though, elodea that's not quite as problematic, but it's one of the dominant plants that are in your finger canals, and that's kind of what you see a picture of on the left side there. It's a native elodea. The other real problem, submerged aquatic plant that's widespread everywhere, is called widgeon grass. It grows in kind of saline, or not saline, but it likes a little bit more salt in the water, and that's probably something that you get a little bit of you have probably more salt in your water than a lot of the lakes that are up in the top of the mountains, for example. Those are the primary things that were causing problems in the canals in terms of density and that type of thing. Parrot's feather is something that we think you should be concerned about. The picture you see on the left side is one of the canals in the Longview area. So it's a milfoil, the parent's feather's in the milfoil species. It's got that pretty little thing that looks like a Christmas tree that sticks out of the water. If you let it go, that's about 15 feet of water in the middle of that canal there. It'll totally, dominate the system, and you've got it right now spotted around the lake at pretty low densities. Like you'll find patches the size of this, this table in a lot of places. So that's something that's going to be a focus of something that you probably really want to get after before it gets to that point, because then the cost of recovery gets pretty dramatic. You also have an aquatic fern called a zola growing in a lot of the canals this summer. And this is it's a floating plant. It's got a couple little root hairs that hang down underneath it. It reproduces kind of geometrically. They kind of break off a daughter plant, and one of these things can turn into 2, which turns into 4, which if you do the math all day, it gets to look like this. So that's another problem plant. It causes, in terms of, it stops light from coming in, below these mats. So it can cause all kinds of chemical changes in the water, and you want to get on that before it kind of gets loose. Then the last thing we observed was you're starting to get problems with cyanobacteria, or harmful algae blooms, and you probably have seen the signs where the lakes are closed from time to time, but these are that blue-green stuff that's kind of floating on the shoreline there. I'm going to talk a little bit more of that at the end, but just briefly, cyanobacteria produce toxins. They don't do it all the time, but they can produce toxins to the point where, like pets, for example, that drink out of the water, there's an acute liver toxin that they produce, there's acute neurotoxin that they produce, and if they ingest enough of it, it can be a problem. There's also a couple compounds these things make that are directly linked to ALS, or Lou Gehrig's disease. There's clusters around the northeastern United States where all the water for the city is coming out of a reservoir, for example, drinking water reservoir that's the eutrophic lake, for example, where the rates of that are dramatically higher, and that type of thing. And lastly, some recent studies have found that these things can aerosolize and blow around if you got a pretty good wind. So when you get through the, here's what's out here, here's the problems that you're facing, then you start looking at what are the control options you've got that'll deal with these problems on the scale you've got them. And that's kind of the next thing we're going to talk about and run through. So we've got a bunch of, like anything else, weed control, you've got chemical control technologies, you've got mechanical control technologies, there can be some biological control technologies available, and then physical control, which is, in this case, is probably more, a homeowner, clearing his own beach and that type of thing, and we're not going to spend a whole lot of time talking about that, but that type of thing. So the only biological control tool we have for aquatic plant management is triple-A grass carp. And they're a fish species that is native to the Amur River in China, and I'll get into that in a second. And when you're stocking a lake with any kind of a biological control agent, you get a curve that kind of looks like this, where you start out with a high population of the problem, whether it's an aquatic weed or whatever, and then you stock the biological control agent, and eventually they start eating each other. One will go down, the other will go up, and eventually they'll kind of plateau out where you can reduce the problem, but you generally don't ever get rid of it. And that's kind of the whole idea behind classical biological control. So grass carp they're a fish that's native to the Amur River. It runs north out of China into Russia. It's actually in the minnow family. It got saddled with the name carp somewhere along the line, and that, the European brown carp did a lot of destruction in the United States, and somehow so a lot of fisheries biologists just don't like it because it's got the name carp attached to it. But it's a fish that consumes aquatic vegetation. And it's one of the probably more cost-effective things you can do to target aquatic plants. So it's something that you've used here in the past. You probably still have grass carp that are alive in your system. I think you see them float, cruising by from time to time. They basically spend all day eating weeds. So if you throw one grass carp in a lake, it can eat plants all day, and you never see any difference. You can throw 10 in, and you start seeing an impact. If you put too many in, they eventually get ahead of the growth and they eat everything. And then you've got no vegetation at all. You just have a sterile system. And that's something that they're trying to avoid by making you buy a sterile fish that won't physically reproduce, and that's why they They're called triploid fish. They do have feeding preferences. They'll eat things like, right now you've got the two weeds you've got in there, the Canadian or the smaller Elodea plant and the widgeon grass. They really like that. They don't like Eurasian milfoil, which you still have a bit of in the northern part of the canal system. So they won't really eat it, and they don't chew on things that are like pennywort, the emergent wort, because there's too much tissue in it. But they do have a potential role. If you're going to use these things, you can't just put them in there and they'll eat. The first thing that happens is mortality. If you put 100 fish in, bass will get a couple, the osprey gets some. So at some point, the number of things you've got out there trying to help you will drop off. Also, as they get older, they don't eat as much, so you generally have to kind of put more fish in from time to time. In our state, they let you put 6 fish per vegetated acre in. So you have to map the acres you've got, and you have to get a permit from the state. And just a funny story, the first permit we ever submitted for a small golf course pond, we had it's like a 1 acre pond. We told them we had, I can't remember the number, maybe 1/4 of an acre of vegetation. They sent us a permit pack for 2.7 fish, because that's what his calculator said when he did the math. So we rounded up. So, but that's something that's, it's got some potential to help you reduce your problem. I guess the other thing about grass carp is you can't necessarily, let's say you've got a problem, you want to deal with it in one of your canals, they're not going to stay put, right? They're going to roam around, they're going to go where they want. So they've got that kind of a thing, but they can thin the population out. You just have to make sure you don't stock them to the point where they get ahead of the weeds. So a couple physical things. Bottom barriers are widely used, not so much on a scale where you're doing acres because of the expense, but these things are real handy for like homeowners going after submerged aquatic plants. This is one you attach a material to the bottom there. You get 100% control where you put it. You got no control where you don't put it. So it's something that homeowners can use a lot and do use a lot to kind of keep areas clear and open. Generally, they have to be attached to the bottom, so they're not. You get gas buildup underneath them, so you have to make sure you do a good job of attaching them. And most of them have a way to vent the gas. And you do have to kind of maintain them from time to time, but it's something that is pretty effective at a smaller scale. The primary problem with them, it costs $2 or $3 a square foot to buy and install these things. And if you think about an acre, there's 43,000 blah 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 square feet in an acre. So the cost of doing it on any large scale is pretty dramatic. Diver dredging and bottom barriers are the other kind of option people have. Diver dredging just is a system, now they call it DASH, which stands for Diver Assisted Suction Harvesting. It can be effective, it's used largely in pretty clear water lakes to go after pioneering infestations of something like Eurasian milfoil, where it's just kind of coming into the lake. But what a diver does is he's going around and he's got a hose down there, he's kind of collecting the plants and putting them into the hose. The hose brings them up to a basket, it's collected up there and kind of goes over there. So it can be a pretty effective way to do it if you've got, there's a couple things that kind of limit it, but it's an extremely effective way to deal with small things. The limiting factors are visibility. If you don't have clear water, they can't really see what they're doing. Those things impact production. Cost of divers, prevailing wage isn't an issue because we have a ruling from the state that says this isn't a kind of a public work type thing. But you still have to pay, you have to pay them money they're working out there all day, and it's a kind of a unique trade, and so it gets expensive to do it. So those are kind of the things that limit that tool. Aquatic plant harvesting is an extremely effective way in a lot of cases to go after aquatic weeds. This is a machine we're using this is down the Withlacoochee River in the middle of Florida. We're harvesting hydrilla here, but the harvesting systems are basically paddle wheel driven boats. They've got a front cutter head that has a conveyor belt in it. As they drive along, the knives cut the material. It comes up a conveyor belt onto a storage deck, and then as the machine fills up, it has to go to shore and get rid of the stuff. So there's two aspects to a harvesting operation. You've got an operation on the water where you have to have a piece of equipment that's out there cutting the plants, and then you have to have a shoreside operation where you're taking the plants and putting them somewhere. And it makes good compost. Most of these aquatic weeds are about 90% water. You can have a pretty good sized pile and it breaks down pretty quick, but The advantages of something like harvesting is you get instant results. You don't have to wait, like herbicide or grass carp, for example, you have to wait for some period of time before you see results. With a harvester, you're cutting the plants, you're getting results right away. The species of weeds you got in here don't generally grow back as fast as some of the real invasive plants, so that the cutting lasts longer. You're adding nothing to the environment, which is kind of a key for some people. You can export nutrients. Nutrients, there's nutrients tied up in the biomass that you're taking out of the lake, and whether it's it may, so when you are exporting nutrients, whether it makes any difference or not is kind of a function of how fast they're coming back in from somewhere else in the watershed, but that kind of thing. And then it is something that has potential impacts. A lot of people think, well, there's no impact. Well, a lot of times these machines will collect fish that are tied up in the vegetation. They'll collect invertebrates that are living on the vegetation, those types of things. So you can remove, you can be removing organisms and that type of thing. So this is kind of what it looks like. You've got a machine that's on the water. You've got it gets a full load, it comes in. There's a couple different types of conveyors people use. Most of the contractors use what's called a trailer conveyor, so it's basically the boat trailer that launches the machine. And it also has a conveyor deck on it. So the machine comes back, it mates to that, it unloads onto the conveyor, and then that conveyor takes the plant somewhere else and disposes of them. Usually you try to get something pretty close to the lake. So the primary thing that drives harvesting operations in terms of production and in terms of economics is how far the machine has to go with a load. If you think, for example, you have a harvester that if it's just running all the time, it can cut probably 2 or 3 acres a day, but at some point it gets full, right? So then you have to take it somewhere. If the harvester has to go 2 or 3 miles to get rid of stuff and come back, it's spending the economics, and the cost of harvesting an acre goes up dramatically. If you can have a machine working pretty close to boat ramps or other places on the shoreline where it can kind of come to get rid of it, it can be a pretty cost-effective thing. So that's what drives it. And in your case, you probably are going to, there's areas that it might make a lot of sense and be pretty productive in terms of, how it's working for you and the cost and everything. There's other places, though, where the runs to get rid of the material are so long that it may, be cost prohibitive. But that's something that we've got some ways to kind of calculate and help you with. But the more access sites you've got on the shoreline, or something, the more access sites you have on the shoreline, the more economic something like this becomes. So there's 2 ways people do this. There's contractors in the western United States that own equipment that'll show up and harvest for you. They generally charge a mobilization fee, and they generally charge somewhere like $2,000 a day for their equipment, and that's variable. I mean, that's kind of what we pay if we're hiring somebody. And then the production they get out of that is totally a function of the things I just mentioned, whether the machine can get rid of, if it has to, like I said, if it cuts 1/10 of an acre and takes 2 hours to get rid of the stuff, then the production is low. If it can work pretty close to the boat ramp, it can go up. If you're going to buy one of these things, the next size up from the one I just showed you a minute ago costs about, you're probably looking at about $300K in a capital investment, and then you've got to have people to operate it. You've got to do daily maintenance and things like that. So that's kind of the economics of what it is. But the key thing is looking at mapping your boat ramps and kind of figuring out what the distances are away from the areas you want to harvest. Just a couple quick things on immersion control. There are machines that we use that can kind of cut cattails and things, and that's not something your group really wanted to focus on, but just to let you know that those are available. So last thing I want to talk about is herbicide technologies. And right now, there's 3 processes that regulate the application of herbicides in waters of the United States. The first is the EPA registers these products. They've got a program, a national program, where a chemical company has to take them a compound that they think they want to sell for an aquatic herbicide. There's a battery of tests they have to go through that's dramatically a higher bar than most herbicide type products, because you're putting it in a 3-dimensional environment. The water can move. If you're treating a golf course, for example, the fungicide, or your lawn with something to kill dandelions, it's going to stay there, right? If you put something in water, it's got the potential to move. And so, there's drinking water, there's irrigation water, there's those types of things. So EPA now, it takes about $20 million and about 10 years of research before a company can get a decision, a yes or no decision on where they can ever sell the product. So they generally don't start down the road with something that they're not going to be able to sell. So the US EPA's got a battery of tests. They have to prove that at label rates it's not going to impact fish, it's not going to impact drinking water supplies, those types of things. And once the product's registered nationally, it can then be used across the country, but most states then have another system you go through. In our state, you know, in Iowa, for example, they're not worried about salmon, right? They might be worried about bass or something. In our state, you know, the primary thing is salmon. So Washington State further regulates these things. They've got an environmental impact statement for every herbicide that they've got on their permit that basically is they've determined that it can be safely used in Washington State if it's used according to the permit and according to the label. And then the applicators are basically licensed and trained to go out and put it out. So those are kind of just quick background on that. There are contact herbicides, which you guys have used. There's those things, they're systemic products. So a contact herbicide is something where you put it in the water, it's going to get into the plant pretty quick, it's going to control the plant that's above the hydrosoil, it's not going to translocate down and get into the roots, but it's pretty effective season-long control. And then there are technologies that are systemic, which means it'll translocate, kill the entire plant, and that plant will never come back. But those are more usually specific to different species. And then lastly, the Environmental Protection Agency in the last 10 years have come up with a new category called reduced risk herbicides, and these are the things they think are extremely safe to be used, and according to the label, most of them can be used in potable water reservoirs without any restrictions on delivery of water and that type of thing. So there's a couple of those that we're going to talk about. So herbicide efficacy, you have to, it's a three-dimensional environment, so you have to, contact exposure time is real critical. If you're doing a herbicide application, you have to understand how fast the herbicide gets in the plant. You have to understand what the water dynamics are, if you've got flowing water, those types of things. They kind of help you pick the product you use. But basically, the idea here is the plant has to get exposed to this stuff long enough for it to take in a lethal dose, and that's something that's kind of critical. So contact herbicides have kind of been what I think you guys have been using to this point. Diquat and Aquafol are two of those that are common in Washington State. These are fairly cost effective on a per acre basis. They provide season-long control. They will knock the plants down there, but a lot of times they'll come back the next year, so you kind of have to do it repetitively. There is a fish timing window on the permit that kind of requires applicators in a lot of lakes to wait till July 15th to use a couple of these, because apparently July 15th is the day all salmon go to the ocean. So another product you've used in the past is Sonar or Fluoridone. Sonar is a trade name. This is something that probably has application for you. In the past, this particular herbicide, it doesn't kill the plant, it stops it from making a pigment that's critical to protect the chlorophyll from the sunlight. So chlorophyll, you probably remember from high school, is the thing that makes food for plants. The carotene pigment is the pigment you see in the fall when your trees, the chlorophyll's gone, the leaves are red or green or whatever. That pigment protects chlorophyll from the sunlight. So Fluoridone, or Sonar is the trade name, if you keep it around the vegetation for 6 to 8 weeks, it'll basically starve the plant to death. And they've got newer technologies where a lot of these, in the past you guys treated your whole lake system with this, I think, because you had to do that to keep the stuff around the plants you're trying to treat. They now have controlled release pellets where you can spot treat like canals and things like that and be pretty effective with it. Procelicor is another herbicide that just got registered a couple of years ago by the Environmental Protection Agency. It's extremely effective on parrot's feather and Eurasian milfoil, which are two of the problems you guys have. And it's something you could probably think about for that particular thing. It gets into the plants really fast. It's selective, which means it kills the milfoils. It won't touch any of the other vegetation in the water, that type of thing, and go from there. So just a couple quick, post-treatment things. Last thing I want to talk about is the harmful algae blooms. So we did some water quality sampling. So you probably know that the lake's been closed a couple of times for what they call HABs, or harmful algae blooms. And these things are a species of algae that are these toxin producers. And we did some water quality monitoring on the lakes as part of this. And phosphorus is the thing that drives these particular, I'll get to a slide in a minute that explains that, but a eutrophic lake or a hypereutrophic lake is generally got phosphorus levels that are somewhere around 35 to 90 micrograms per liter. A hypereutrophic lake's over 90. Well, Duck Lake is looking pretty good, but the two canal systems where we sampled, you had pretty extensive levels of phosphorus, and that's the thing that's driving these harmful algae blooms. So I already talked about that. Just there are toxins that are produced by these things, and that's why you want to deal with them. I did mention that there's some scientific papers now that have made direct links between these compounds and those types of things. But generally what happens is people are coming out and closing the lake. The health department will take a sample, they'll see that the toxin's there, and they'll put these signs up or something similar, and the lake's closed. So there's two ways to deal with harmful algae blooms. There's reactive technologies. There are algicides that can be used to treat them. And this is just a couple of quick examples. There's an Ironman competition on Lake Wilderness the last couple of years, and you probably know Ironman there. You have to swim a bunch of miles, you have to ride 100 miles on your bike, and then you have to run a marathon. You can probably tell by looking at me, I've never done one of those. But they had a toxic algae bloom 2 days before. They had 3,000 athletes coming in. They had a toxic algae bloom pop up about the week before the event. And there are a couple algicides you can use. The primary one we use in Washington State is basically hydrogen peroxide, so it breaks down to oxygen in the water. But it wipes out the algae, and it'll also get the toxins. Just another larger scale project. About 4 years ago, the California Aqueduct takes water from the Delta down to Los Angeles, and there's a reservoir right on the end of that thing called Lake Silverwood that takes water to about 4 million people. And they had a bloom that basically halted them from delivering water to 4 million or 5 million customers down below. So same type of thing. We did one of these peroxygen treatments, and it got rid of it right away. So there are, I guess my point is, there are tools you can go out and target algae when these things are a problem and kind of get the thing removed, but preventative strategies are probably more important. So we've got a couple ways to monitor that. In your case, we've got a couple of these algae buoys deployed in each of the water bodies that they measure chlorophyll, which is a measure of the biomass of algae, and then they measure phycocyanin, which is a pigment that's unique to these toxin producers. So it kind of just broadcasts every day kind of what the conditions are, and we've used that to kind of help monitor. So from a longer term perspective, I'm going to talk about grants in a few minutes and then be done, I think. The primary in-lake tool to deal with these things is nutrient inactivation. And I mentioned that phosphorus is the kind of the driving thing. And if you look at this slide, on the up and down axis on this side is total biomass of algae. If you look at on that side, if you go up and down, you'll see there's a bunch of different species of algae there. So on the bottom axis is phosphorus. So if the phosphorus levels in your lake are low, the toxin producers don't have a competitive advantage. A lot of the beneficial algae that are an important part of the food chain thrive. But as the phosphorus levels go up, you'll see the cyanobacteria population goes up and up and up, and that's because they can, plants need nitrogen and oxygen, or nitrogen and phosphorus to grow, right? And the cyanobacteria can get their nitrogen they need from the atmosphere, which is unique. The other species of algae can't do that. So as your phosphorus levels go up, they have a more of a competitive advantage, and the algae biomass goes up, but the percent of the biomass that's a toxin producer skyrockets. So the idea behind nutrient activation is to take the phosphorus and shove it back down to the other end of that scale. And there's two ways to kind of go after that. One of them is aluminum sulfate, and that's a technology that's been around for 40 years. It was developed by the United States EPA Lake Restoration Program. You basically come out and make an application, it forms a flock, and as it goes down through the water column, it captures the phosphorus molecules, it binds them, and then it kind of sits on the bottom and keeps the phosphorus from releasing from the sediments and fueling the growth. So that's just an example of a project where that's used. Canyon Lake's a project that we're doing alum work on in Southern California, and it was on the 303D list as impaired waters, and they've been able to take it off by doing these kinds of treatments that have been pretty effective. And we do quite a bit of this around Washington State too. Another technology is called lanthanum, which is a rare earth element that does the same thing. It captures phosphorus. This is Kitsap Lake up near Bremerton. They've been closed, I think, every year for for like 2009 or so up until 3 years ago. It was closed every summer, for most of the summer, for toxic algae blooms. So kind of same thing. There was a map made, calculated the water volume, made the application of a lanthanum-based product that kind of, the same thing, settles down through the water column. Done it 3 years in a row. Their SecuDisc readings, or water transparency, has gone from about this far to about 20 feet, for example. So they've had no closures ever since. It's quick before and after shot. So I've got 2 more slides here. The one thing I wanted, and Steve corrected me, there's 2 funding things that you can get. The Department of Ecology has a funding program. When you register your boat trailer, you pay $5 or $10. That all goes into a freshwater aquatic weed fund. And that fund is available to municipalities or government entities that have some kind of a relationship with a lake. They can do one of these plans, and they can submit to get whatever the group decides is a function that they want to. When this plan is written, they can basically take the plan and apply to get funding to help implement it. And they can get up to $75,000 the first time around to kind of jumpstart something like that. There's also, the Department of Ecology has a freshwater algae grant management program, and I think that's something your group ought to probably pursue, because the number of acres you've got in the, it's not going to be something that's probably going to be easily funded by homeowners, that type of thing. So they've got a program where you can kind of go out and get a grant to study the lake from an algae perspective and come up with the dosing and everything, and then you can apply for funding to implement that. So that's kind of what we've done to this point. I blew through that pretty quick, but the next key steps that we have to do to complete this thing is we have to solicit input, which is what we really wanted to get back from you guys today. What do you think about these technologies? Which ones make sense to you? Which ones don't make sense? We want to capture that and include it in the document, and then we're going to go back to the steering committee and kind of come up with the grand scheme of what the community wants to do, and then we'll hit the print button and you can start using it. So with that, I'll shut up, and I really encourage people to to really talk, answer questions and that type of thing. So she was behind me. So
yeah. So did you look at the causes of the increased phosphorus, and is there a relationship between the larger macrophytes dying and laying down in the canal systems, increasing phosphorus levels?
we looked at a snapshot of this summer, right? So a lot of these lakes have been, phosphorus is coming in from the watershed for decades. It usually cycles. So it gets into plant tissue, it gets into algae cells. As they die every year, they fall down, they decompose, and eventually it builds up in the sediments. You can get a little bit of, you're probably not adding anything in terms of pounds of phosphorus. What you're probably doing is changing the form of where it is. Like you might be changing it from a weed, a massive weed problem into available in the water column for, that's one of the things that lakes that they've overstocked grass carp, that happens all the time. They eat all the vegetation and they kind of, poop it out the back. And then they, it gets tied up in biomass, but they will, they get a shift where they haven't changed the pounds of phosphorus that are there. What they've done is they've changed where it is, and it's fueling algae growth. So, that's what you're studying. You need to do a lot broader study than what we did. We sampled a couple of points in time, and then Steve's got the systems that are kind of tracking what's going on. Did that answer your question? Or? Okay.
Yeah. Can you kill some of them weeds by increasing the height of the lake?
I don't know if you can hear him. He asked if you could kill some of these weeds by increasing the height of the lake. And the answer is basically kind of yes. But it really depends on water clarity. So plants need light to photosynthesize. Even in Lake Tahoe, you get down to a certain depth and there's not enough light for a plant to grow. But usually, so at some point, you can do that. I don't know how much you can raise your lake. If you raise it a foot or two, I don't know that it would do you much good. But you've got kind of two different systems too. If you notice that slide, The Grand Canal system is where most of the vegetation is. You get over in Duck Lake and there really isn't anywhere near as much. And that may be a function of grass carp over the years. But
How deep is the layer of soft muck, specifically in the Fish Hook, the Bell Canals, and the Grand Canals? You know, just approximate, is it?
I don't know.
Well,
what that map does, it's not showing you depth. It's showing you the hard. It's a sonar signal that's bouncing off and it's recording. It's showing you the hardness of the bottom. So typically, the harder the bottom is, the more consolidated, and it is. The softer it is. So it's not giving you an exact measurement. But if you've got the really soft sediments, you can assume that they're deeper. But you really have to go out and with a probe or something to measure it if you really want the exact number. But that thing will tell you. I mean, you've got access to all this data. That thing will tell you what's where.
Thank you.
Yep.
Yeah, I moved out here in 2019 and retired out here, expecting to be able to do some bass fishing. And I'm telling you what, I'm really disappointed with what's going on out here with the weed killing. I don't prefer herbicides.
Yeah.
I know that probably we just don't know how else to deal with it,
Yeah.
except that I prefer harvesting over anything else. I don't think we've really adventured into that very much. I think we've touched on it some. We have our own harvester.
Yeah.
I'm with the Waterway Committee.
Yep.
And so we do have a harvester that we're trying to get
Yeah.
going again.
You're-
One harvester ain't gonna fix it all, though. We need more than that.
Yeah, well, one of the key things, so the year I was president of the National Aquatic Plant Management Society, we signed an MOU, Memorandum of Understanding, with BASS, the National Bass Angler Sportsman Association, because a lot of their members were spreading Eurasian milfoil and hydrilla all over the southeastern United States, because fish need plants, right, or they need some kind of structure. But what was happening was these reservoirs would fill up with this, it would basically destroy the habitat. So we hired the biologists at Mississippi State and Auburn, and we funded a bunch of studies, and the conclusion really was you need about 27% of the littoral area of the lake has to have some kind of structure in it, whether it's an aquatic weed or whether it's a tree or whatever, for a bass population. If you optimize it at about 27 or 30%, the bass have a really good relationship with their prey, right? So if you have too many weeds, what happens is the bass can't find their prey, and they get stunted and they die out. If you've got not enough cover, the bass eat everything, and then there's nothing to eat. And that's kind of what that study came up with. So it's critical, and you notice that fisheries was one of the key things that the steering committee came up with in terms of the problem statement and the things that you have to do. So you've got to protect areas that have structure in them around the lake if you're really going to optimize a bass fishery.
Yeah, but we haven't done that.
Yeah, and you might have to go back and
Herbicide and everything.
yeah, you might have to go back and if that's a real concern, you really need to sit down with a map and think about, protect this area, protect this area, protect this area. Try to do that where it's not impacting people and that type of thing. But harvesting can have a pretty significant. There's 2 or 3 papers that were published by the Wisconsin DNR where they studied the fish harvest or aquatic weed harvest, and they figured they're collecting like 25% of the year of the young bass by the harvester was, right? So those things aren't technically without an impact on a fishery. But the critical thing is to have habitat and structure, and aquatic weeds are the easiest way to do that. So the other thing you look at that map of Duck Lake is there's vegetation down there, but it's not that high, right? It's not red, it's not up to the surface where it's bothering people. So those would be areas you'd want to leave alone and kind of encourage, because there's vegetation there that's not, it's not bothering the other beneficial uses. But
It's not just bass.
yeah,
Bass, crappie, sunfish.
Well, yeah.
I mean, if you look at the report from the Department of Fish and Wildlife, they did a fish study starting in 2000, all the way up to 2014, and it's just absolutely went down like this to where there's
Yeah.
nothing left.
well, you
I
look
mean,
at
if you catch a bass out there.
Well, you look at that map of Duck Lake. There's really no vegetation, right? So I mean, you
Got to have 60%. We need to have 60% vegetation in order to have a good fishery.
Not according to Mississippi State.
I've been bass fishing for a lot of years,
Yeah.
and there's a lot of weed growth where there's fish.
Yeah.
And there's that's just
Yep.
that's what supports
So I
the
think
fish.
part of the plan is you really need to, the groups really needs to think about where do we protect habitat for fish, you know, and where does the, but that's all part of the whole, you know, the objective shouldn't be to kill weeds. The objective should be to manage aquatic vegetation where it's impacting some beneficial use. So, I don't know if that is.
We need to do more harvesting.
Yeah.
That's what I think.
Okay. Well, I think they're going to do a pilot project this summer, I think. And Steve, is that, you want to talk to that at all, or?
I know, we are.
Yeah.
Yeah, I live in a little inlet in the south end of Duck Lake. Duck Lake's pretty clean, but that inlet is gross. There's all kinds of vegetation in there, and we got algae blooms in there all the time, in that little inlet, where the rest of the lake is not affected. What's the best way to clean those inlets out?
There are a couple of water circulating systems you can buy that are pretty effective, like just mounted on your dock, and they're electric, and they'll push water like from here to the back of the room almost. So I think part of the problem, if you got the prevailing winds coming out of the north, you're probably getting all the algae cells piled up down on that end of the lake, you know, during the course of the summer. But I mean, that's one solution that a homeowner can kind of do to keep vegetation away from their dock. But in terms of treatment, you got to be on the treatment program, right?
Need to get it out first.
Yeah.
Well, I think at one time we had talked about the end of the inlets there where it really does get bad. Isn't it is it possible to put a water flow system toward the ends of those that would help us rather than just at one dock?
Yeah, there, you know, there are multiple down a couple of docks. So there's mechanical systems that move water, and there's machines that are, you know, maybe this big, run off 110 volt you can plug in, but they'll seriously push a dramatic amount of water. So you can put a few of those down an area on both sides. And those types of things are. Then you have to have permission from property owners if you're starting to go much beyond that. Does that answer your question or not?
We seem to be putting this on property owners where it's actually the flow of the water coming in and going out. And I'm not sure that it's the property owners themselves creating the problem. Possibly some with chemicals that they're using on their grass. I can understand that, and we've been encouraging to stop that. But it has been discussed where a water circulation system at the end would probably benefit, and I'm not sure why that would be a homeowner rather than a city. The city benefits from the entire canal.
Take notes. We'll get that in your comments in the system.
Thank you.
Somebody over here, one?
Yeah, so did you measure oxygen? Is there a likelihood that low oxygen levels and algal blooms could be impacting the fish communities?
Yeah, we didn't. You know, oxygen is when you take an oxygen read, it's a snapshot of what you do, what's there the day you put the instrument in, right? We looked at stuff and you had pretty good oxygen, but oxygen changes daily, right? If you got algae and aquatic plants in you know, every plant on the planet, whether it's your grass or your lawn or the algae in the lake, they photosynthesize all day and they produce oxygen, right? And then your lawn kicks that all off into the atmosphere of the world. The algae kicks it off into the atmosphere of your lake, so it's more of a confined space. But at night they respire, which means they consume oxygen and they kick off carbon dioxide. So you can have a daily oxygen profile where you come out in the morning, you know, at noon and on a sunny day in the summer, and the oxygen levels are pretty high lake-wide. Come out at dawn and they can be crashed down to nothing. So the more aquatic plant growth or algae you have in your system, the more of a fluctuation in oxygen you're going to get every day, and that can be, you know, problematic. So part of the process of taking the algae cells out with something like a phosphorus precipitation treatment is you reduce the population or the density of the cells, and that gets a lot better. I don't know if that answers your question or not. But.
Yeah, I was just actually asking, I mean, in a way, but with your snapshot, there's no way you can know whether those problems would be affecting the fish populations.
The densities you've got algae, it's probably not helping. There are monitoring buoys. We've got an algae monitoring buoy in the lake, right, in 3 spots right now. It basically phones home to mama every day, and you look at a screen. We've got oxygen sensors deployed the same way. You could buy a buoy And we've got probes that hang down, and same thing at radios, what the dissolved oxygen is doing. So we've got a couple lakes in Southern California where people try to grow trout in 80-degree water. And that's kind of where we have those. But there's a technology available that you can do that. And it's not outrageously expensive. So.
Can you clean that stuff up with a sump pump?
Can you clean it up with a sump pump? Maybe.
4-inch, 6-inch sump pump?
Well, we can use like trash pumps. That works pretty well. I mean, you just have a suction and you kind of move it into a. Those diver dredges, the way they work is they have they've got a pump that pumps water down to another big hose, and the water coming back up the hose forms a venturi, so the vegetation never goes through a pump.
Oh.
So that's kind of how those work. So at some point it gets clogged, I think.
Well, I could put this on my
Yeah.
dock and dry it out and use it.
Yeah. Yeah. Can I go to the back? There's some questions back. Yeah.
Hey Terry, I digress a little bit back to the weed management and the options. And you showed it on your slide with harvesting about the trapping of fish. Steve Borba and Grant Schaefer and I last summer went out into Fishhook Canal, and we were actually manually harvesting the pennywort.
Huh?
Pulling it out, loading it up on the workboat, and dumping it. And we didn't do large areas. We were experimenting to see how well, and coming up with new ideas to do it. What I want to emphasize is that when we pulled this up on the boat, I actually rescued 2 little bass and this was in over 3 trips we took. We were pulling out little bass out of the pennywort as it came up on the boat. So you will lose fish with the harvester.
Yeah, and so what happens when you're driving over these harvesters, you're looking down this conveyor belt that's coming up, and there's always a bunch of little fish just swimming in there, right? If you get going too fast, they catch the plants and up they come, and then they're in the storage deck. So harvester, a lot of times contractors are trying, they're trying to produce, right? You can slow the boat down, and you can reduce the amount of fish take, for example. I mean, there's things you can do to limit that, but you're probably always going to get some. You're also taking out the invertebrates that live on the plant tissues. And my only point there was, a lot of people think that there's no environmental impact from harvesting, and my point is that there can be. None of these things really, if you look at every one of those technologies, there's probably a plus or minus to it.
I'd like to add too is that when we were doing it, one of the things that really amazed me, because people talk about how we're killing off these waterways, but when we were pulling the pennywort out of there, you would not believe the number of snails in there. There are a lot of snails in this water system. So it's not like it's toxic for living creatures.
Yeah. Do you have a question somewhere over here?
I was just wondering, when you use a harvester and you were talking about how you didn't want them to have to go too far away to dump it, like every so often they do it during the day, why don't they get those great big trash dumpsters from LeMay or whomever and dump it in that? Once it sits there for a while, it compacts down to nothing. We do it every year on our dock, pull it out, put it on our dock on a tarp and let it dry out, and by the time it's ready to go in a trash can, there's not very much left.
Yeah. So I don't know if you heard that. She's saying that, why don't you take the harvesting material, like have LeMay spot some things along, and that makes sense. I mean, my point was, you have to think about that. If you're going to spend X number of dollars to let's say you want to control 10 acres of weeds in a canal, and you've got these choices, and these are the costs to them, and the cost from harvesting can be real competitive with a chemical, for example, if you're working pretty close to where the thing is. That was my only point. The cost is going to go up the farther the thing has to run. There are machines that, like conveyor, there's other high-speed transport barges where, they've got a barge that'll take 6 or 7 loads of the harvester, and then it can just leave and the harvester can stay. So there's things, you can spend more money, and if you decide that if the decision of the community was, we want to implement a harvesting program, you just have to have the right mix of equipment based on the number of weeds you're going to cut. A good example is Green Lake in Seattle. They've got 200 acres of Eurasian milfoil. They bought a harvester that'll cut about 1/2 an acre a day. So they the thing works all day, it never accomplishes anything all summer. So the point there is if that's your goal, you really have to think about the economics, and you have to have the right equipment mix to put the pressure on the problem that you're trying to solve. So, yeah. Hi.
I bought on the lake down here in the early 80s, so I've seen a lot of these presentations and a lot of the status. Our lake was filled with fish.
Yep.
It was reasonably clear. There were lily pads around the fringes. And then the milfoil came in with the bass tournaments. And we had a harvester here, but the harvester just chopped the weeds
It can.
and spread the milfoil throughout the system. Then various things. I mean, we've done the grass carp.
Yep.
And actually, I think it was ecology that told us grass carp was a bad idea because when they consume a lot, they leave a lot of nitrogen behind.
Well, yeah, they talk about grass carp and nutrients and things. They leave the night. They don't leave. They basically change it from where it used to be into somewhere else.
Into
They don't-
somewhere else.
Yeah. So.
But as time has progressed, the lake is no longer clear, or the waterway in front of my place. In the olden days, they would do a chemical treatment every couple of years that was pretty effective. It kept the growth down.
Mhm.
The last few years, it seems like everything we've done has popped out on the other side. And of course, there's so many more houses here.
Yeah.
Can you address what individuals can do to keep their lots from contributing to the mess?
Okay, well, she's asking, so the primary thing is nutrients, right? And fertilizers, a lot of people talk about fertilizers, but I think in our state they've gotten rid of phosphorus fertilizers. They passed a bill a bunch of years ago. And so, but phosphorus fertilizers didn't generally contribute much to a lake because you put a fertilizer out, you water it, it releases the chemicals. When phosphorus comes off a fertilizer pellet, it binds pretty tight to soil particles. What nitrogen you put more nitrogen out than the lake, than the soil that your lawn can take, that can leach, right? So nitrogen is a bigger problem. So you want to look at trying to reduce the amount of fertilizers you're using, but that's really a key thing. And a lot of people also try to encourage more of a native shoreline because it provides more habitat instead of having just like your lawn down to the water or whatever. But some people like that too.
We're supposed to have that buffer zone.
Yeah.
But that has been very difficult for our folks to enforce with the
Yeah.
natural water.
Do you have a code enforcement thing?
We have one code
Can
enforcement.
you guys hear this
officer.
or not? We're having a big discussion with ourselves, right?
I wanted to find out, is the carp the only kind of fish that we can have up here? Can we bring in tilapia so we can get a fish industry going with tilapia?
Well, the big problem with tilapia is they can't stand water they'll die if the water gets below 60 or sometimes maybe even 70 degrees. Like they'll use it in irrigation canals in Southern California and they'll find all summer and every one of them dies in the winter. So tilapia is a tropical fish. The grass carp are more of a northern fish. And tilapia eat algae. They don't really do much to the submerged aquatic plants. But the big problem with them is they just won't survive.
The other question I have for you is, we have fowl, not only fish in the, on the canals and stuff, but we do have birds.
Yeah.
And by using, you mentioned something about hydrogen peroxide.
One of the algicides that is pretty effective is hydrogen peroxide based, yeah.
Yeah, would that affect the birds? Because I know
No.
as humans, we use it ourselves.
Well, so my dog ate a chocolate cake, which is supposed to be poisonous, so you call the vet, they say, pour a bottle of hydrogen this stuff down his throat. I'm going, you kidding me, it'll kill him, right? And of course it doesn't. It basically just foams up. But hydrogen peroxide is basically water and oxygen. That's what it breaks down to. And when you're putting it in as an algicide, it basically oxidizes the algae cells, and it oxidizes the toxin they produce. So and then it breaks down really fast, and so it's kind of that treatment is, you can use it to get relief, but it's not going to fix anything for the long term. That's why you want to kind of look at the nutrient thing. So. Yeah.
I just wanted to to add on to a comment that you made about the bags. Talking to someone about the harvester that we have here, that's the way they were doing it. It was basically bagging, and they had a separate boat that would come and take it, so there was no downtime on the harvester, cutting costs, being more productive that way. So do you see any downfall in that at all?
The machines I've seen that do that are pretty small in nature, and I mean, they're fine if you're doing small areas, but if you start doing pretty large, if you're trying to do 100 acres, they just don't, I don't think they've got the production capability. Those types of machines for bigger jobs are probably the most, I mean, people have been trying to build harvesters that are a better thing for, hundreds of years, and it never really evolved past, for large jobs, what I'm showing you there.
So I understand it's small, but if we already have it here, we're not purchasing or leasing or renting from someone to where it can be utilized every day, would you think that would be capable then of handling it?
It would be capable of handling whatever area was, I don't know what the production rate of the machine is, right?
Okay.
It would be capable of doing whatever it's capable of doing in a day type thing. But the idea behind these plans, though, is not to pick, I want to use a herbicide in every situation. The idea behind these plans is to try to get the best mix of all these tools to solve the particular problems you have. And problems change over time. Like I said, when you first did this plan decades ago, this lake was overrun with Brazilian Illadia. It was really, it was a massive, massive problem back in the 90s. And the grass carp that they put in there were targeting and cleaning, I mean, they did a pretty good job of fixing that. And then something else comes up. So these things they should be a living document too. They, like right now, we found almost no Eurasian, well, not, the Eurasian milfoil problem we've had has been whittled down dramatically, but there's still little patches of it here and there. So it makes sense to use a selective herbicide like Percellacor to target those small areas so they just don't go nuts on you again. But then harvesting might make a lot of sense in some of the other areas that you've got. But the idea behind this plan is these are the two technologies, these are how they work, these are the pluses and minuses of each of them. And what blend of this can we afford as a community to deploy? So, yeah.
So my biggest takeaway right now, if I've assimilated all the things you've presented, is in our canals, not the lake, but in our canals, the primary problem may be phosphorus, and the weeds are a result of too much phosphorus, or am I missing something here?
From my sense of being out here this summer, the place I see the algae the most is in Duck Lake and Menard Lake. The canals, the water was clear. And so the aquatic weed gets most of the nutrient it needs from its roots, just like your trees do, right? Algae cells are single-cell plants. They have to get the nutrients they need dissolved in the water column. So if you've got really low levels of nutrients in your lake, then algae can't go nuts. But the aquatic weeds can still be a problem. So does that answer your question or not?
I don't think I framed my question correctly. So my algae is one of my concerns, but the overabundance of the aquatic weeds is a major concern. And if we reduce the phosphorus, would that have an effect on the aquatic weeds?
Okay, he's asking if reducing the phosphorus will have an effect on the aquatic weeds, and the answer is to some degree, but there's still legacy phosphorus in the lake sediments that's going to be there that they're going to be driving from. Like, for example, we treated Lake Tahoe this year, right? It's got a Eurasian milfoil problem, and it's getting expansive, and there's really no phosphorus, or the nutrients in that lake are extremely low, but they still have, those plants are getting everything they need from their root system, not from the water column, whereas maybe that gets there or no?
When you use the aluminum, whatever it was.
Sulfate or
aluminum sulfate,
or the
does that bind the phosphorus that's on the bottom that you're talking about?
Okay,
now?
so he's talking about, so what both of those treatments do is they settle down through the water column and they grab the phosphorus that's in the water column and they sink it, and then it coats the bottom. And what it'll do is there's a bunch of chemical processes where phosphorus can release back into the lake from the sediments. That cap will sit on top and will stop that from happening. So once you take the phosphorus out and you cap the sediments, you're not getting a release of phosphorus back into the water column every summer, but an aquatic weed can stick its root right through all that. So basically, the only way to get that kind of phosphorus out is to dredge out the sediment, which is outrageously expensive.
Okay.
Okay.
So the last thing that I would ask is you presented kind of a three-prong approach, and one of them is binding the phosphorus that creates the clarity in the water, but then some combination of herbicide and harvesting is probably the direction that will be effective in our water body.
I'd say probably, yeah. I mean, those aren't decisions that I make. Our job basically is to present the tools and the options and that kind of thing. But if you really look at, if I looked at this thing and it was my lake, I think what I would do is I would try to use a selective herbicide like Percellacor to target the Eurasian milfoil and the parrot's feather, because that particular herbicide will kill those plants. It won't touch anything else. It doesn't. There's kind of two families of aquatic weeds. There's broadleaf plants, and there's most aquatic weeds are in the grass family. If you think about like treating your lawn for dandelions, the grass family and the broadleaf plants, you can put like 2,4-D will kill the dandelion and it won't touch your grass, right? Well, the same kind of technology works. There's milfoils in the broadleaf, so we have broadleaf herbicides where we can selectively target those two invasive species that are going to be real problematic for you if you don't go after them. So that's the first thing I'd do. The second thing I'd do is look at these native plants and then make a decision on the economics and then the opinions of the community on what's the best way to go after them. And I would think that some combination of herbicides and contact herbicides like you've been doing and harvesting would make sense. I don't think the harvesting, the cost is what's probably going to drive that. The cost of harvesting 200 and some acres is going to be astronomical. The cost of doing a smaller number of acres closer to a boat ramp or someplace where they can get rid of the stuff is going to be a lot more cost effective. So I think some blend of all those things would probably make the most sense if because you're going to have X number of dollars, right? And what you have to do is say, it costs us this much to do this much to do this. What's the best mix of these things that we can do to get to manage the problem so it's not impacting our beneficial uses? I don't know if that answers your question either, but
It does.
that's what I do. If it's my lake, that's what I do.
I'd like to give other people a chance, but
Yeah.
I do have one more question.
Okay.
So you mentioned that you were on one of the canals and it was clear, and you were on another place and it wasn't. Have you ever been on Bass Canal?
Yeah.
You know how brown it is?
Yeah.
You know it wasn't like that last year?
Yeah.
It wasn't like that until after they herbicided it.
Well, don't get me.
I know, but I'm just saying, it got really clear, and it had a lot of weeds in it.
I was on Bass Canal in 1993, I think.
Well, I live on there.
The same, just there's brown water, it's volcanic acid or something.
And I could catch bass right off my dock.
Yeah.
But after they came in and herbicided it, it turned it brown. I couldn't even catch it.
Yeah.
I couldn't catch nothing.
That particular herbicide you're using, Diquat, is.
Well, they did the whole canal rather than sections of it, and they just killed the whole canal.
Yeah.
And that's what's wrong with our herbicide, and we're killing too much at one time.
Well, that's the other thing. You need to sit down as a group with a map and say, we need to protect habitat here, and we need to not. And that's the kind of thing that the community really has to kind of get together and decide what to do. And I think you're doing some of that now.
Isn't that what we're doing now?
Well, I don't know. I mean, I think that somebody's putting a treatment map together, right? You need to find that guy.
Yeah, I know who he is.
So how the aquatic herbicides that are approved in Washington, how disease-causing toxic are those herbicides?
They're not. Diquat, the one you're using, is used in fish hatcheries, in salmon and trout hatcheries, when the fish are, baby fish or millions of them together in a tank. They control a couple of gill diseases and bacterial diseases in fish hatcheries at 10 times the rate you're treating the weeds in the lake with. So the herbicide itself is not having any kind of an impact on fish. And you cannot, the EPA will not register a product that's going to have an impact on fish if it's used according to the label. So those things don't really happen.
So are any of the aquatic herbicides carcinogens for human beings?
No. No, well, not the ones that are registered for the lakes, no.
Exactly.
So
that was my question. Thank you.
Yeah.
I lived in the lake for 20 years, and we found out that the dead spots in the water, the very four fingers, were the ones that were the contamination part, and the main reason was because of circulation. The water just didn't get a chance to move in and out of there. So what I proposed would be to circulate to where you could put circulation in Bass Canal by putting a channel under the road there. I think would be the least expensive. And the second thing was, I think we need to have more tournaments up here for fishing. And we need to promote that with some of the money we're using for the herbicides to get the boaters up here and to get the water moving around again. And it also would help the restaurants here in town and the hotels.
Yeah.
So we've got a beneficial use going all around town. And the second thing I would, or third thing I would bring out on this is maybe we could take some of the money we're using for spraying, which is in the thousands of dollars a year, and set that aside for maybe a restocking of some of this, like grass carp and some of the things like that. So we've got a constant infeed of vegetation here,
Yeah, I think from a fisheries standpoint, you really have to look at the forage base. The bass is the apex predator, right? It's the biggest thing that's out there. And a lot of people are fishing for that, but if they don't have food, if they don't have adequate, sunfish, shiners, all those kinds of things. I don't know what the fisheries guys will generally come out and shock a lake and figure out where you are. I don't know how often they've done that, but it's a good idea to make sure, if you've got some money to put back into that stuff, you can put structure out there, you can, stock the right, mix of forage and big fish. You could really improve a fishery pretty dramatically by spending some money on it.
We had carp up there that weighed 6-7 pounds.
Yeah.
So I mean, you could see them swim up right to the docks.
Getting all that? Yeah, thanks. Anything else? Yeah.
Alrighty, so there's been a lot of question and answering period. I want to make sure, thank you very much. I just want to make sure, because once we're done tonight, Terry is going to get this IAV MP completed, and there is no more public comment. I want to make sure that out of everybody who's come tonight, that you have voiced your opinion on the weed issue. All right? There's also a little bit in there about the algae, but we actually are, the Fresh Waterways Advisory Board, we are actually looking towards doing a possible algae study. Okay, so for those who attend our board meetings, you'll hear a little bit about that. But again, I want to make sure that any comment, whether it's for, against herbicides, for, against harvesting, anything dealing specifically with the weeds, that everyone here has had an opportunity to voice their opinion. Okay, I can't ask her, again, I'm not going to be able to answer a question, but you have an opinion?
I just want to say something.
Okay.
So I'm on Carew's Corner on the Bell Canal, and we have a lot of milfoil and whatever. It gets thick. You can get it out in the center of the canal. My complaint about the spraying is that they don't do it till July 15th or after, and now I know why. And it irritates me because my children and my grandchildren come to visit me in the summer and want to be in the water, and they can't go out there and use the dock and the boat and whatever because there's so much garbage, and then it's sprayed, and then they can't get in the water then, and we have to wait for it to clear.
Okay.
So I'd like it
Some
sooner.
of those reduced risk herbicides I was talking about have different fish timing windows, so they're not subject to the fish timing window at all. It's a particular one you guys have been using has a fish timing window. So there are things that could, like sonar, for example, or if you've got milfoil, that Percellacor, you can start putting that in the water in, April or May if the plants are there. It's the not every herbicide on the permit is subject to the fish timing window, but the ones you've been using are.
So I will address that real quick, all right? Is there actually is how this works is that the contractor will come out, what we've been using in the past is Doug Dorling, Northwest Aquatic Ecosystems. He's done it since 2007. There is a contract, it's called the PSA, Performance Service Agreement, that is established between Doug Dorling and the city. And under that contract, he will come out around May timeframe, okay, and he has to do that sonar, like what you saw that Terry had up there with the map of the red, yellow, green, and all that. He has to put this huge report together. That gets submitted to the city and advisory board. The advisory board, we have a meeting and we discuss exactly what is going on. We discuss where the if there's any herbicide treatment, where the herbicide treatment should be done. We submit all of that back to the city, and it is for the city to approve, disapprove, and whatnot. Always in the past, they've gone with what the advisory board has recommended. Then that goes to the contractor again, and he schedules it. Okay? So as you see, there is this process. It's not just a matter of, well, let me just get on the schedule and do it at this particular time. So there is a new PSA that will be done in accordance with the new biennium budget, and the city's already working that up. And once that is received, then the advisory board will work with whoever is contracted, and we will try our best to get whatever we need, whether it's herbicide, mechanical harvesting, whatever the case may be, done sooner rather than later. So we have a lot of lessons learned over the years, okay? And that is definitely one of them, okay? Is there anyone else who has a comment?
What is the synergistic effect of the combination of chemicals we've been using?
Can you answer
I
that?
didn't really hear it. Say that again?
What is the synergistic effect of the combination of chemicals that we've been using?
Synergistic effect in terms of what?
Health-wise.
Health-wise? Well, so every chemical that you have, whether it's in your medicine cabinet or whatever, it boils down to the dose makes the poison, right? So you could drink a bottle of a pesticide and it'll kill you. Or a better example is this, acetic acid, right? If you drink acetic acid, it'll kill you. If you mix it with oil and vinegar and herbs at a dilute enough rate, it becomes Italian dressing. But what you're talking about, I don't know exactly what you're talking about. The chemical that's going in the water has been approved by the Environmental Protection Agency to go into the water and not impact fish, human health at the rates that it's being put in the water. Now, there are chemicals in the past that have been banned because they'll have some off-target impact. Like EPA was formed in 1972, and the first law they enacted was the regulation of pesticides because of all the stuff that was going on with Agent Orange and DDT and things like that. So I don't know if that answered your question or not. But
Well, the EPA does not technically do safety on humans. And
there's a significant component to that in these products.
And by federal law, they're not allowed, pesticide manufacturers are not allowed to put that their product is safe. And glyphosate is a perfect example that the EPA approved them, and then residents have to prove that it's killing us. And the problem that I have with pesticides is killing not only us and harming us and our children, and poisoning the fish, poisoning the beneficial insects and all the plants. It's killing everything that's living. And mechanical means, okay, you have a lesser evil, you're going to kill some of the fish by removing them. But with pesticides, you're killing everything. You're poisoning everybody.
Well, I disagree with you, but you're obviously entitled to your opinion. So.
The thing is, with my generation and the next generation, we're getting sicker and sicker with every generation, and the environmental toxins are a huge key player in that. And
okay.
Yeah.
Well, we'll roll that down, so it'll be in the report.
Is there anybody else who has a comment?
Didn't you have a chart, or I think it was the guy that does do the...
Doug Gorley.
Yeah, and he had a chart of how safe it was and
Yes,
what
he
was
did.
worse and stuff like that.
Yeah, yes.
So maybe...
That was at the December city
Yeah.
chat, yes.
So maybe that would tell you.
Just 1 second, Richard. Yes,
They don't
So,
test.
so basically, when it's time to do all this, put all their plan together, they're gonna assess both chemical and mechanical at the same time. Are they gonna be looking at all the canals? Because I know someone had mentioned that their canal was just like dead, and I live on Emily B. Hanna, which is one of the real small ones, and it looks pretty bad a lot of the time.
So Doug, when he comes out and he does this, so, well, I don't know who this next contractor will be, but they come out and they do everything except Duck Lake proper, okay? So anything north of the Fishhook Canal into Duck Lake, that's not done. It's done maybe about every 5 years or so just to see what's going on. And it was just done last year, okay? But all of the canals and Lake Menard are done, okay? Including Bass Canal for the survey. Last year we did not treat Bass Canal, and that was listening to the residents, on Bass Canal. Joe Hubachek was one of them. But I also got feedback from some residents who wanted to know why we didn't treat. So, you know, whatever. But what we'll do again this year is we will, again, that document will come in and we look over the whole entire document. For the last 3 years that we've been doing this, we hold special meetings and we're a lot of thought going into it, wanting to make sure that we are listening to the residents. And we will come up with a mechanical harvesting, and it will probably be on your canal. The 2 north canals, that's where we're going to do it. That's why your canal looked really bad last year, or in 2022, because we were going to do mechanical harvesting. It didn't work out.
Well, you know, I clean around my dock
you
as
do.
far as I can go out in the middle of the canal. And I was beginning to think that I was doing myself a disservice, because when I can't stand it, I go out and clean it all out. But then they come along and spray, and all the plant stuff's gone, and I think that I'm not benefiting from it, which is why I object to the July 15th.
Yeah, no, we hear you, we hear you. Yeah, 2020 was a really bad year. It didn't get done until actually way in late July.
Late.
Alrighty, so any other comments?
Can we get a schedule put out, like what areas have you guys done, and when's the next time you guys gonna be doing any kind of treatment? If we can have like a routine maintenance
I do that.
schedule?
It's called a Fresh Waterways Advisory Board meeting. And we put all of that stuff, it actually goes on osgov.com as well. Sarah, our city clerk, she posts that stuff. And if you come to our meetings, we talk about all that. So it's there.
Not just for the day that you show up, oh, by the way, we're gonna be doing this now. Something that we can look at for the future, what's coming up, you know, what's the agenda down the road? Is there, can that be done?
I'll talk to you after the meeting. I'm not really talk about agenda. I'm not exactly sure.
Steve, what I wanted to ask is there an email address where if any of us have any additional questions or comments, that we can get them to that email address that then gets to Terry and his team so that it can get included in this IVAMP?
All right. So my city email address is citysborba, B-O-R-B-A, at gmail.com. If you submit it to me, you would need to have any comment by what date?
We could do it in a week.
All right.
I think you captured pretty much everything everybody said, didn't you?
Yeah. And I've given, everyone's been given an opportunity. One last time, anyone have a comment that you want to make for the IAVMP?
Thank you for doing it.
Thank you.
You still have meetings at the Elks Club?
No, they're at the city library.
City library?
Mm-hmm. Yeah, first Monday of every month, unless it's a holiday, 2 p.m. at the library. The next meeting is Monday, 2 p.m. at the library.
We live off of Bill Canal. I got out with my hip boots and pulled all the weeds that I could get up. Just got a little ball on the end of them. I got stuck in the mud.
Yeah.
I had to take my hip boots off and grab a hold of the dock to pull myself out of the water. She was in town shopping, and I thought, well, here it is. So
The end of the world.
dredging and clean that out and get a flow through the canals is what we need.
Yeah, there's actually, you know, again, and the mayor said it best as soon as he was introducing this, is that this is actually going to be our first step. There really hasn't been in the last, well, more than decade, any real study of our waterways. And I am pushing with the city we got the money, the funding for the IAVMP. We're going to be working out a possible algae survey, a lake management study, which also there's a storm water master plan. And everyone should know by now that that is what our waterways are there for, right? Everyone gets that. It's the stormwater holding facility, right? So the stormwater goes into that. And it falls under that. That's what gives us the money to do anything with the fresh waterways, anything, buoys, anything whatsoever, is what you see on your utility bill that says storm drain or stormwater fee, right? That is what gives the money to do these things, okay? So we're working on that, and again, we do have the meeting, and city clerk is at every one of them. She does it via Zoom as well. I give everybody an opportunity to do a public comment. And or if you're not available during that time, you can go back and listen to the meetings. They're all there. And you can listen to those, and you can come to the next meeting or send us a comment. Ma'am?
What are we looking at? Is anything going to happen this summer? Any harvesting? Is anything going to happen this summer?
Well, yeah, that's what I just said. We're working on
I know
a
you're
harvesting
working on it.
plan. Yes.
But this is already-
We have money. We have money set aside. The city gave money, $45,000 that will be used for harvesting, and yes, we are going to do it. We don't know how far $45,000 is going to get us, but that's what we need to check it out. It's going to be a very expensive process. Alrighty. For the IAVMP?
Yeah, is this presentation available to look at? I can put the PowerPoint to I can make both the PowerPoint and a PDF of it and get it to these guys, and they can distribute it. So
Once I get it, I'll ask the city clerk to place it on the website. Alrighty. Okay. Yep.
If we purchase a harvesting boat, is it possible to make payments on it and also possibly even rent it out, which would bring money to the city to cover costs?
Are you asking me? Or?
Either
well,
one.
basically, people finance these things. Like a lot of times, you can get a lease. Like if a contractor was going to buy one, he could lease it over 5 years, and he would just have to make a decision if he thought he could recover his income, and he probably could. So there's leasing options. There's you can get a loan for them. Sometimes there's like a dedicated fund, like I don't know if your stormwater utility or your lake thing. If you could space the payments out, you've had some way to drive the funding towards it. If that's the way the community decided to go, I'm sure there's a way to fund it. My only point was you have to get enough machines, and you have to have the right mix of machines to actually solve the problem. And that's a lot of times, that's the one thing that people don't do, is they don't spend enough money on the right mix of equipment. So you really have to sit down and think about the acres you're going to treat and how long it'll take. But it's an effective way to go about managing the weeds. So.
All right, one last one. Jane.
It's just my comment is I would like to see, we have a harvester. I would like to see how efficient that is and operate that, because it doesn't require that extra barge. It is something that we already have here. So that, and also along with some water flow in the inlets there to get that moving.
Well, actually, I want to clarify something with that, what you just said, is the city does not have a harvesting machine. This Fresh Waterways Corporation has a boat that they can attach a harvesting mechanism to. And there is, well, they've walked out here. I know, Richard, you know what I'm talking about. But if you come to, I think we'll probably talk about mechanical harvesting. We're not on Monday, but the following meeting we would. And you'll learn a lot more about that particular harvester and what it's capable of. It's not even put together right now.
Yes,
Okay, so there's a lot to that. Plus, just so you know, the people who have to do that are volunteers. So, all righty. Okay, so, all right. Thank you guys very much.
So they're going to attach it to the workboat.
To what?